Hello, my dear friends. Welcome to Class 9 Science. I am Soham Jagad. Welcome you all. We are in chapter number 2, and till now we have discussed about what is solution and what is suspension. Before that, we have seen that what is pure substance, what is mixture, what are the types of mixture, that is homogeneous, heterogeneous. Further, we divide it into solution, suspension, and colloidal solution. From these three, we have seen solution and suspension. Now, let's look onto the colloidal solution. So we have our topic of the day, that is 2.2.3, that is colloidal solution. Important topic, little bit different from other two topics. The mixture obtained by group D in activity 2.2 is called colloidal or colloidal solution. Colloid or colloidal solution. Remember, this is not the definition of colloid or colloidal solution. In exam, you do not have to write this. The mixture obtained by group D in activity number 2.2 is called colloidal solution. That is not the definition. This is for understanding purpose. Let's recall in activity number 2.2 what is the mixture with group D. Here you can see a few drop of milk or ink to group D, which means the group D has few drops of milk or ink with them. So that is what we called as colloidal solution or colloid. Here also we deduce from the activity that group D has got a colloidal solution. So let's see what is colloidal solution actually, what are the properties of colloidal solution. The particles of colloid are uniformly spread throughout the solution. As we have seen in solution, there are solute particles in solvent. Similarly, in colloidal solution, we have colloid particles uniformly spread throughout the solution. Due to relatively smaller size of particles as compared to that of suspension, which means here the particles are small, but in comparison with particles of suspension, particles of solution are smallest. Next, particles of colloid or colloidal solution, that is little bit bigger than that of solution. And after that we have particles of suspension, that is the largest from all three. So I hope you can remember the size of these three particles in sequence from smaller to larger. The mixture appears to be homogeneous. Remember, the mixture appear to be homogeneous. Read. But actually a colloidal solution is heterogeneous mixture. For example, milk. Here the colloidal solution is looks like a homogeneous, but it is actually heterogeneous mixture. For example, milk. So the colloidal solution is actually heterogeneous mixture, but it looks like homogeneous mixture. So if in exam we are asked for type of mixture, that is colloidal solution, we have to write heterogeneous mixture. Let's see. Because the small size of colloidal particles we cannot see them with naked eyes. As we have seen milk, ink, we are see in our regular life, but we cannot see the particles are there in milk or ink. So the particles are smaller that we cannot see with our naked eye. But these particles can easily scattered beam of visible light as observed in activity 2.2. In activity 2.2, we also observed that mixture with group D can be scattered visible light beam. So this scattering of beam of light is called Tyndall effect. Important question and definition. What is Tyndall effect? So the particles in the mixture which can scattering the beam of light, this effect is called Tyndall effect. After the name of scientist who discovered this effect, which means scientist Tyndall discovered this effect. So after his name, this effect is called as Tyndall effect. Remember, Tyndall effect, scattering of beam of light, that is called Tyndall effect. Tyndall effect can also be observed when fine beam of light enters a room through a small hole. Sometimes in afternoon time or maybe any time of day, we can observe small beam of light entering into house from small hole in any window or door, and we can see some particles, small, very small particles moving in that, we can see in that beam. So how it looks like, you can see it can be looks like something like this. You can see this is not actually a small hole, but this is the window from which the light beam is coming, and here you can see the scattering effect of light by which the path of this light is visible. Path of this light is visible. So this is nothing but the Tyndall effect. So this is Tyndall effect. You might seen it. If you do not see till day, now onwards, if you see any this kind of thing, you have to remember the name Tyndall effect. As I told you, if you do not mix science with your everyday life, you cannot remember or understood it easily. So remember, try to relate science in your everyday life. So that is what about Tyndall effect. This happens due to the scattering of light by the particles of dust and smoke in the air. You can see in that light path that very small size of dust and smoke particles are there. In smoke, you can also observe Tyndall effect. In smoke, you can also observe Tyndall effect. So this is due to particles of dust and smoke. Here in figure 2.3, you can see that the solution of copper sulfate do not show Tyndall effect. Here you can see in this glass, which means in glass A, we cannot see the path of light. Here the light beam is passing through this both container glasses, but in glass A you cannot observe the path of light, while in glass B you can here observe the path of light. So that is what we called Tyndall effect. Path of light become visible. You can see here path of light become visible. Mixture of water and milk show the Tyndall effect. So here we have in glass B mixture of water and milk. So this is the solution and this is colloid or colloidal solution in glass B. So glass A is not, in which we cannot observe light of path of light, while in glass B we can observe path of light. So here is small activity. You can also do this activity at your home. In place of copper sulfate you can take salt also, but the condition is that the salt and water should be pure as much as possible. Otherwise you can see here also a light path of light rays. So water and salt both are in very pure form, so you can clearly not visible this path of light. Tyndall effect can be observed when sunlight passes through the canopy of dense forest. Here two places are given in our textbook for Tyndall effect. You can find another example also, but here we have two examples. First was the Tyndall effect can be observed when fine beam of light enters the room through a small hole, and another example is Tyndall effect can be observed when sunlight passes through the canopy of dense forest. Canopy means a layer of trees form when they are densely packed. So here in this figure you can observe, here we have much clear image of that canopy also. Yes, here you can see. Here you can see the path of light that is visible. This is what we call Tyndall effect. This is the picture of forest, and in which you can see path of light when light enters in jungle. So that is about Tyndall effect. In forest, note it, mist contain tiny droplets of water which acts as a particles of colloid dispersed in air. Remember this? In the forest, mist contain tiny droplets of water which acts as particle of colloid dispersed in air. So we have seen what is Tyndall effect. The particles can easily scatter the beam of light, and the scattering of beam of light is called Tyndall effect. Where we can observe the Tyndall effect, we can observe Tyndall effect in a room when fine beam of light enters in the room, that is due to particles of dust and smoke. We can also observe Tyndall effect if we pass the light ray through mixture of water and milk. We can also observe Tyndall effect in forest when sunlight passes through the canopy of dense forest, and that is due to the tiny droplets of water, that is mist, is dispersed in air. So these all are example of Tyndall effect and the definition of Tyndall effect. Now important topic, that is properties of colloid or properties of colloidal solution. As we have seen in above text paragraph, colloid is heterogeneous mixture. The first point in the property is type of mixture, that is heterogeneous mixture. The size of particles of colloid is too small to be individually seen by naked eyes. As we have seen that the particle size is bigger than the solution, but that is not enough big that we can see by our naked eyes. So the size of particles of colloid is too small to be individually seen by naked eyes. Third point, colloids are big enough to scatter beam of light passing through it and makes its path visible. As we can see that, and we observed in above activity, that colloidal solution can scatter path of light ray. So here we have as a property that colloids are big enough to scatter beam of light passing through it and makes its path visible. They do not settle down when left undisturbed, that is, colloid is quite stable. Colloid is quite stable. They do not settle down, as we have seen in suspension, that if you leave the mixture of suspension, the particles will settle down. But here in case of colloidal solution, it will not happen. You cannot see the milk while put it aside or in fridge for 1 day or half day. You cannot see that the milk particles is settling down and the water is separated from it, that we cannot see. So here we have point, do not settle down and they are quite stable. They cannot be separated from the mixture by the process of filtration. By filtering the milk or any other colloidal solution, you cannot separate disperse medium and disperse phase. What is disperse medium and what is disperse phase, we will see now. But a special technique of separation known as centrifugation can be used to separate the colloidal particles. Here, note it and remember, the special technique to separate colloidal particles, that is known as centrifugation. That is known as centrifugation. We will study this centrifugation process in this chapter only. For time being, only remember that the process that needs for separation of colloidal particles, that is centrifugation technique. So here the properties cannot be separated mixture by filtration, but we can separate the mixture by the special process called centrifugation process. So here we have properties of colloidal solution. Quickly go through it. A colloidal solution is heterogeneous solution. Size is too small, cannot be seen by naked eyes. Big enough to scatter a light beam passing through it and makes its path visible. Do not settle down, hence it is quite stable and cannot separated by process of filtration, but we can separate it by special process called centrifugation. Here I would like to tell you one thing. Here you can see I marked all this point, and you can see the marked point are only important point. You do not have to mug up all this sentence. A colloid is a heterogeneous mixture. the size of the particles of colloid is too small to be individually seen by naked eyes, you have to just pick the important word that we called as keywords. You just have to put keywords from whole paragraph. You note this keyword in your notebooks, separate notebooks, and while you revise the question answer, do not revise from this textbook or any other material, but try to revise it from your notes that you are making. That should be precise, correct, and as short as possible, so you can revise it quickly. For example, in properties of colloidal solution, in first point you just need to write heterogeneous mixture. While writing in exam, you can expand this sentence that a colloid is a heterogeneous mixture. But while revising it, you need not to write full sentence or read full sentence. You can easily remember the key point, the key word, and that is only important. Remember, you do not have to write, you don't write these short words in exam. You will write full sentences, well structured sentences in exam. But what I am talking about is for revision and quick revision that you can do from your short notes. So that is what I can say about short notes. And you have to observe this marked point that I highlighted. This point is important keywords. So you have to focus on these keywords. Let's move ahead. The components of colloidal solution are the dispersed phase and the dispersed medium. As we have seen in a solution that it has two component. Which two component? Solute and solvent. For solution, it has two component, solute and solvent. So here in colloidal solution also we have two components called dispersed phase and dispersion medium. Dispersed phase and dispersion medium. The solute like component or the dispersed particle in colloid form the dispersed phase. So what is dispersed phase? You can relate solution and colloidal solution. So the colloidal solution and the solution in which both has two components. The solute is like dispersed phase. Solute is like dispersed phase. So the solute like a component or the dispersed particle in a colloid forms the dispersed phase. And the component in which dispersed phase is suspended is known as dispersing medium. As now you can remember the point from solution that solute is dilute in solvent. So this solute is related to dispersed phase and there is a solvent is related to dispersing medium. So in dispersing medium we have dispersed phase. We will see some example of this so you can easily remember and understood very clearly what is dispersing phase and dispersing medium. First of all, you remember the comparison between solution and a colloidal solution, and what is two components of each of them. Colloids are classified according to the state. Colloids are classified according to the state. What is state? We have now know solid, liquid and gas are the three phases of the dispersing medium and dispersed phase. Colloids, as we have seen, there are many kinds of mixture, and so colloids are also mixture, and the colloids are classified according to their state, like solid, liquid, gas, and which are the dispersing medium and which are dispersed phase. According to that, we can classify the colloidal solution. A few common examples are given in table 2.1. From the table you can see that there are very common in everyday life. So here from table 2.1 we can see that there are many common examples of colloid. We have already seen it, use it, observe it, but till now we have not known that these are colloidal solution. For example, we have seen fog, cloud, mist. That is the example of colloids. And this type of colloid is aerosol. That is aerosol. So you can easily predict that this is aerosol, which means something is mixed with air. So air is gas. So dispersing medium is gas. And in gas, the dispersed phase is liquid. So in flow, fog, cloud, mist, the liquid, which means the water particles, is dispersed phase. Gas, that is air, is dispersing medium, and this types we call as aerosol. So aerosol, in which dispersed phase is liquid, dispersing medium is gas, and the examples are fog, cloud, mist. Here as a dispersing medium as gas, we have second type also as aerosol, that is dispersing phase gas, dispersing medium as gas, and solid particles are mixed in dispersing phase gas, that is smoke, automobile exhausts. You can see small soot particles in automobile exhaust, as well as when we burnt coal, when we burn wood, smoke. So that is smoke, automobile exhaust. That is a type of colloid that called aerosol, and in which solid particles are mixed in gas. So larger quantity is of gas. So dispersing medium is gas, and the smaller quantity is solid. So dispersed phase is solid. So here we have example as aerosol, that is the mixture of gas and solid. Another example of foam, you can see here the foam, we use word foam. Example of foam is shaving cream, we have seen shaving cream. Now we have foam also in shaving cream, direct foam. So that foam is liquid plus gas, liquid plus gas. The larger quantity is of liquid, so dispersing medium is liquid, and in which gas is there, so dispersed phase is gas. So foam is example of colloids, that is liquid and in which gas are there. So gas in liquid, that type of colloids are called foam, and the example of foam is shaving cream. Next we have emulsion. Emulsion is liquid in liquid colloids, which means dispersing medium and dispersed phase both are liquid. For example, milk, face cream are the examples of emulsion, that is liquid in liquid colloids. After that we have sol, that is example of solid in liquid. For example, milk of magnesia, mud are the example of colloid, and that is sol type of colloid in which solid dispersed phase dispersing in liquid. So these are some example of types of colloid.